Good afternoon. Welcome to the IETF95-GROW meeting. If you're not in the room for GROW, you should go. All right, we're going to get started as soon as I log in. Come on, computer. There we go. All right. So this is the GROW meeting. I'm Chris. This is Peter. Oh, there's a note wall that you can barely read. That's intentional. Oh, maybe that's the only one. Okay, now we have agenda bashing. Anybody want to add anything to the agenda that's not currently on it? Or something you'd desperately like to talk about at the end? Okay, good. Quick draft status. Oh, I'm gonna stand up. Sorry. Okay. So when you present, you have to stand in the pink box for Alvaro and whoever is going to present for the other draft. Sorry, I didn't catch what that was supposed to be. We have the filtering threats stuff is off in the editor queue. Route leak problem definition is off in the editor queue as well. Or no, sorry, it's in the ISG evaluation and I think IETF last call now, what I understand. GShut is waiting as it has always been waiting on the last bit. But anyway, I forget what that was about. RPSL VIA has recently expired, and I think we're waiting on an update from Job, who's not here this week. BGP recheck 00 still needs some discussion on some comments, and so does MRT add paths. I think MRT add paths got a lot of good positive review for working group adoption, so we should spend some time looking at that, making progress. The routing policy considerations is off as an RFC, thanks to the ISG folks. And then the last two drafts, GROW BMP is in the editor queue finally, along with route server operations. Okay, so we have two other presentations. Oh, haha, we need a Jabber scribe and a note taker, and then I can restart. Let me back up. I totally forgot. Is there someone who would like to take notes? John's got his hands full, so he can't. And no tools. Rudiger? No? You can take notes, just very quick. All right. Anybody else? I already started, so I can't use the threat of not starting. All right. Notes, Jabber? No? Great, we can just write down basically what you think happened and email the chairs at the end. It'll be great. grow-chairs@ietf.org. And then we need a Jabber scribe still. We can keep waiting, I guess. Ruger, get on Jabber. Come on. Come on. That's even worse. No one wants to do Jabber scribe. Come on. I guess I can make my laptop do it, but it'll be hard for everybody else. Yes?
I can get Jabber, probably taking notes. Since it's my first meeting, I don't know if I'll be that accurate.
That's fine. If it's not perfectly accurate, we can keep track at the end. Okay? All right. I guess we'll call that good enough. Okay. So I said this stuff. We talked about the draft status, all of those. Okay, now we're back to presentations. All right, I forgot who's, okay, great.
Where are the blue sheets?
Oh, they're going around. Forwarded back, oh, the other way. Forwarded backward.
Good afternoon. I'm Liang from China Telecom. Yeah, today's topic is not something new. It is related to some scenarios we familiar with, including the data center interconnection and operators wide area network optimization, and also including the small areas like today we talk about the service function chain. It also relates to the traditional traffic engineering used in the MPLS network, and which optimized overall network traffic and selecting service optimized service for user service. But we think I think the most of the progress we achieve in the MPLS network cannot be how to implement a similar functionality in MPLS in large scale. What's wrong? In the large scale, native IP network backbone is still a challenge. One reason is because lack of the in-cab, decab tunneling technology and the level switching and forwarding path control mechanism in such a network. And another reason maybe depend on the background of the operator used in deploy their network. For example, most of mainstream service broadband fixed line operator in China most set up their IP backbone means of native IP instead of MPLS. So, for example, in China Telecom, almost 90% of internet traffic, say around several tens of terabits per second, transported by the native IP. The right corner of this picture is the typical IP backbone in China. Most because in order to cover a big population, we have to in turn separate the core into metro network and the core, and the metro network covers and aggregate public subscriber IP station, millions of IP subscribers, millions of public subscribers IP station, and meanwhile the core network is a full mesh switch fabric and connect thousands of metro network. So today with the grow up of SDN, more and more operators try to optimize their native IP network by means of concentrated and separated control plane. But we think such traffic scheduling often may become very complex and unstable with the scale of network grows up. For example, when we use the unreasonable control routing policy to the scheduled traffic, may cause network vibration in the runtime. So many operators realized that most of the traffic scheduling work are temporary deployment in the case of traffic congestion control. And if large-scale network traffic readaptation happen, it means you have to reconfigure or you have to increase your network capacity instead of traffic steering. So comparing to the traditional overall network optimization, locally we schedule the traffic locally, and the schedule limited flows have higher priority for the native IP operators. Here's the big picture. Here's the big picture of the overall traffic steering input that the operator try to implement in the reality. Is just a model. Depends on the capability of the operator have. But we can see this consists of three parts. On the top is the quality control, or say the TE server. We also need the information channel for the link state information and the routing information, like the net floor, IGP or BGP link state. We also need the policy control plane, for example, the BGP flow spec or the netconf or something like the PCEP in the MPLS. And so in the SDN context, traffic steering means locally scheduled selected traffic from whole network in terms of traffic operators' dedicated task or the requirements. So the motivation behind this informational draft can be simplified as two aspects. One is improve the utilization of network locally and configure the service path and the related policy automatically. We don't try to enumerate all cases, but just give a brief go fast through the use case. I think the page needs some sentence. Yes, is I think the temporary and sorry, forget it. Okay, I continue. Yeah. Oh, sorry. Never mind. Yeah. The following use case we introduced can be categorized into two dimensions. One is temporary case, another is persistent. Temporary case means that the traffic scheduling happen in the traffic jam and run out of the network's resource, and it happened. The control that SDN controller system can assign the traffic to can remember all the scheduled traffic and rolling them back once your system or the network operation. So on the contrary, the persistent case, traffic arranged in the dedicated device or link permanently and never be rolled back to the original location or the device it originated from once the once the schedule deployment is enabled. So the most case of the following case we introduced can be belong to two categories. Here's the first case is a typical overseas service provided provided by the operator. Between Sydney and Hong Kong, we have three paths. One is direct link between the Sydney and the Hong Kong. We rank this the golden service, and the service for us provide service to golden server with the less latency and the less low packet loss. And the second pass is bypass from Singapore to Hong Kong, and another pass from Los Angeles to Hong Kong. And the left is the silver service we provide with less latency with some degree congestion. And the last, for the bronze user, they have to endurance part of the latency and the low packet loss. It's a similar case happened in the similar case like the previous, just different in the is happened in the between the metro network. For example, the next line, the next pass between the two metro network congest. You can choose another from another pass from the original metro network to destination. It's another case. Different lies in it's happening in the core nodes. For example, the traffic between the C to the core nodes A. When the link congest link happen here, we can alternate choice the path from C to B and A. It's happening in the core network. The previous one is between the metro. It's inside the AS, and the previous one may be the inter AS. This is another typical case for the two ISP or the operator. The middle is the interface between the two ISP. They provide the exchange point in the different city. Once the traffic congests in one link, we can choose another long distance inter ISP link exists between the two cities. Here's another case for the transit AS. For example, once the QoS of transit B here occur, yes, the transit will be preferred, and the same traffic will go through the transit A instead. Here's the QoS. Yeah, here's the OTT requirement. Last one is the OTT requirements. It's derived from the Tencent networks, Tencent company's network. They is a typical content service content provider in China. Has three exists with ISP in the city A, B, and C. They hope to port their service to can choose different port site to ISP, just like we did in the, for example, the local preference setting in the BGP. So they can choose where to port their service to the public subscriber. On the contrary, they also have the requirement on inbound traffic steering. They can choose where the traffic came back. May wish to have choice on entrance for the inbound traffic, but ISP may choose to, operator may choose ignore or even prohibit such attention to affect this path. So the negotiate mechanism is needed here. Here's the requirements we derived from the previous use case. For example, the classification mechanism, the policy decision procedure, and the last one is the negotiating mechanism between the OTT and the ISP for the inbound traffic steering. Yeah, you can summarize that for the native IP network, you have to phase schedule flow automatically with fine granularity is a challenge. We also need a new policy control plane and to provide end-to-end service to end-to-end traffic scheduling mechanism. So we hope the further work will continue to collect more requirements in detail. Thank you.
Joel Yegley. So I see that as an interesting set of requirements. I think one of the observations I would make is that I've seen these requirements before in some places. In many cases, I think there are components that you have as requirements that are actually kind of impossible. And so I have some concerns that translating those requirements into functions is a bit problematic. In particularly with request to scheduling with fine granularity. Like a lot of scheduling that has these long feedback loops results in a tendency to polarize your traffic, i.e. The one that looks best right now isn't going to be the one that looks best in 200 milliseconds when you put all the traffic on there. And all of a sudden the other ones are going to be idle. And those will look pretty good until they get traffic on them. And that can result in a nice tight feedback loop that alternates between a lot and no performance. Yeah. I mean, yeah, it's an excellent robot.
Hi, Chris Morrow. So a lot of your presentation seems to me like you wanted to do software-defined networking and didn't say that. So I think you could do, if with the right set of, perfect, it'll stay on its own. With the right set of computation, you could do what you want to do in your network, right? But it means a bunch of SDN stuff has to happen, a bunch of interfaces to all the routers, all the I2RS business needs to happen. Like, there's a bunch of heavy lifting to happen before you could do this. And then you have to solve some problems that Joel points out. But I mean, it seems like it's a sort of an SDN problem to me.
So I just want to comment on the control system that you need to do. Oh, sorry, I'm Peter Lofberg. The control system math is, you have a PID regulator, and in this case, you have infinite gain and no dampening, and it's proven to be unstable. So it doesn't matter what you do. The recent traffic, if you try to find the math, you look at all these people that do traffic engineering with their favorite traffic engineering tools, you try to figure out what they're actually doing, and you end up finding that, well, what they're doing is they're inserting a delay in the control loop and a random generator. That's the human. So the math for most traffic engineering cases is it's add a delay and a random generator.
Yeah, and this is Joel Yegley again. This is something that we actually model kind of in our own systems with respect to load balancing between POPs, is what is the difference between doing it at random, which has a tendency to result in something that looks like an even distribution, at least at very large scale, and actually making decisions, which turns out to be much harder. So particularly if it's about working around resource constraints that are imposed by other parties, that has a tendency to be another sort of deep game theory exercise, because the other party is also working around some constraints with respect to their posture to you, and so you're actually engaged in a traffic engineering arms race. And so those are things that you know, get fed into models, and they contribute to a set of irreducible complexities that are hard to engineer out of this.
So Peter Lofberg again. If what you're trying to achieve is that slide that says gold, bronze, and silver service, you can actually do that by you can do that by actually doing edge functions, delay, drop. You introduce the crappiness at the edge. For the gold people has less crappiness than the bronze people. And then you add up the statistic sum of those traffics, and then that's your size of your backbone. And now everybody get exactly what they paid for, and you don't need to sit there and send the traffic around.
Rüdiger Volk. Well, okay, evil Peter. Peter's assumption is that you throw sufficient over provisioning into the game so that, well, okay, actually you have high quality and no problems from the start. And then Peter's game works. Not everybody has sufficient resources in all the places all the time. But having sufficient resources is something that cannot be emulated by any magic if you don't have sufficient resources. So kind of my question would be, how much spare capacity or how much overloading is in your problem set? If you are running at 5% spare capacity in the complete network for half of a day, you cannot do good quality service or even tired service by any means of control. Well, okay, if you can afford serious spare capacity, which of course is also needed for securing against failures. Well, okay, I think Peter's notion of, well, okay, delaying computations and tuning of parameters actually works. In an extreme example, it might work like, well, okay, you measure for a week and figure out what the main problems in the load versus the capacity are, and you compute the best distribution, and for the next week, you are at least approximating a good distribution. Ooh, well, you can't.
Sebastian Castro relaying from Java, from Akanshka Jain. How can we schedule flows automatically with fine granularity?
Details. I know, you guys, concerned about the overall I understand what you worry about. One is performance, another is the maybe the granularity. What kind of granularity we want to achieve, and the time requirement between the two scheduling. I can say it is a real requirement in reality in the cooperation between us with Tencent company. They, you know, is the big content provider in China, biggest one in China. They it's the real case. We can answer all your questions one by one, but I can do overall impression on this topic. We have this is the the goal of requirement to schedule the granularity at the main metro network. Here is a very coarse, I think, granularity. But to provide service to Tencent, we provide in very concrete IP address, for example, their video server address or subscriber traffic. For example, New York subscriber visit a Comcast video. We only schedule the New York, part of area of New York's subscribers traffic, not all traffic. Those traffic are high priority of our VIP subscriber. So I limited my topic here locally. Local means inside the AS, just part of the link and the routes. We schedule the traffic, individual traffic, the limited flow. We don't hold the flow vibration between the different paths. And the time granularity is about, I think, 1 week or in the long term over, for example, monthly or quarterly, something like this. So I think I should give more detail on the definition on floor and the requirements next time.
So we're out of time. So I think we need to take more discussion to the list about your draft. I think one thing that would be good to clarify is what your goal is in this draft to understand if it's just requirements, clarifying, educating, or if you have some follow-on plans for what you want to do with the requirements draft.
Okay.
But that discussion needs to take place on the list, and we'll go from there. Thank you.
Okay, thank you all. I make some supplement.
I think Alvaro is coming for the next presentation.
Hi, I'm Alvaro. I did this with Russ and Sue. We've actually been doing this for quite a while. We presented this, I think, the first time, probably before the last time we worked to Berlin. So it's been a while. Last time we talked about this, it actually created a whole bunch of discussion on the mailing list. I think because we didn't really explain the intent of what we were doing. Not the mechanism, it's still the same thing. The changes between then and now are mostly clearing up exactly what this is intended to be. In fact, from the last discussion that we had, RFC 7789 resulted out of that, which talks about potential effects of filtering in the internet. And if you go read that RFC, it talks about the fact that if you filter some things, it may affect someone else's policies, for example. And that's true. The intent of this, of what we're doing, is an optional mechanism. It's there in green, it should be in red in my version, but whatever. An optional mechanism to remove a prefix when it overlaps. We know that there are people that do this in their network for whatever reason. And all we're specifying here is a mechanism that you can use to maybe automate that in your network. Again, this is not intended for internet-wide deployment. We're not saying everyone should go and turn this on everywhere. We're not recommending people to filter anything. We're just saying if you are already filtering, you may want to use this mechanism instead of manually going to put filters everywhere. So with the objective of not getting any spam about IPv6 examples, I'm using an IPv6 example. And all this shows is somebody has down here that's advertising 2 routes, one long route and one short route. They're overlapping routes. And so this guy advertises the long and the short up this way and only the long one the other way. So what happens is, of course, 6503 gets all the routes from everyone else. And assuming that 6503 wants to go this way because of their policy, maybe they make the decision that they're going to filter the more specific route. That won't change their dynamic of the network, right? They will keep going down this way because that's what they decided to do. And in fact, in this example, and I know the internet is obviously more complicated than this, the guys behind him don't see a change either, right? Because it would come this way, he would make the decision to go down this way, and that's it. You go all the way down the line, and period. So again, this is intended to be for the case where you are probably already filtering, like in this case, and you may want to automate that. So just some terminology. There is what we call an overlapping route, which is a longer route, and maybe an aggregate or whatever you're advertising your block is the covering route. So when you go read the draft, that's what it says. We use the term bounded, and all this means is we're referring to a community that we use, which is a normal community that you can put and define yourself in your network. The intent is that if we're going to filter the overlapping route and you retain the route in your network, that's the intent of bounded, right? For you to bound the propagation of the route. And then in the draft, we talk about fully overlapping. So what this means basically is that if you receive the route from both overlapping and covering routes from the same peer and they have the same AS path, that means that they're functionally the same. And so like in this example over here, the routes coming from 65,000 will have the same path and the same next hop for 65,003. So if you remove one, the longest one, there's functionally no change for 65,003. The draft does say that if you really want to do some other type of overlapping filtering, let's say, for example, routes that came from different peers, that's up to you. We're not telling you to do it or not. So there's 4 obvious steps to this thing. One is obviously identifying and marking the overlapping routes. You can, by looking at them or by having the router analyze them, you know which ones are overlapping and fully overlapping, for example, AS path, next hop, and marking them with this bounded community. Again, this is just a community you use, locally significant to you. Then what we want to do is, of course, prefer the marked routes so that if we're going to bound that more specific, we don't want not only that route, but other more specific routes that match it to escape our AS. So we only mark the overlapping route with the bounded community, and we make that be preferred inside our AS. Like normal stuff. How do you do that? You can do a local preference if you want to, or our preferred mechanism is, of course, to use a cost community that is going to prefer that. In the draft, we say use the absolute value of the cost community. Inside your AS, you can optionally, if you want to, not install that route, the routing table. It's marked. You can, if you want to not install it, you propagate it still, of course, so you can filter it or compare it using the cost community. And then what we're saying in the draft is that you should not, if you're going to go through all this stuff, you should not advertise this to your external peers, right? The whole purpose is that you're already filtering and you're replacing those manual filters with this mechanism. You probably should not advertise this to external peers. The draft goes further to say that if you do, you may want to put no export in the route. So what would happen is this same drawing as before, same routes. Now what happens is with 65,003, router A gets the 2 routes that come from down there. Then router A would notice that they are overlapping routes. So we mark the longest one with the bounded community. As that gets distributed through the AS, for example, through router B, they would get the same longer prefix. The one with the bounded community, because we're using either local preference or the cost community, would just be preferred. That would, of course, router C, of course, would get that as well. If you're implementing that should not advertise externally, then 65,004 would only get the shorter prefix. Again, from what we talked about before, this doesn't change the dynamics of the routing. And this is my last slide, I think. Yeah.
Alvaro, Peter Lofsberg. What is sent from 65003 to to 65002 and from 65002 to 65003. There's no arrow there. Is 65002 kind of disconnected for this prefix or what?
No, yeah, sorry. You're saying that this arrow is not there?
What's the policy on that wire?
Yeah, correct. So we're assuming here in this simple diagram that everyone's just advertising everything to everyone else. So what that means is that yes, this slash 64 is propagated from 0 to 2 to 3 up there. Right? So normal propagation. Of course, what would happen is 65,003 selects its best path, and we'll try to advertise it out there as well. In normal BGP propagation, we're not assuming any other policy in there at all.
K. Patel, Cisco. Excellent proposal. Should consider it. Now, most implementations do take into account that if the least specific route and the most specific route are encountered at C, and the next hops being same, they can auto aggregate. I think you can extend it to say, if the more specific route comes from a different next hop, and you've seen the instance of more specific route coming from the same next hop as well, you can auto aggregate it, which will effectively increase the scope.
Right, exactly. So we didn't put anything about aggregation here because the mechanism right now is sort of a general mechanism. We don't know if 65,003 actually owns the block and they can aggregate and all that stuff. But yes, it's the same concept on the outgoing of what we're doing on the incoming side.
And to just finish to that, you should probably make a reference to add paths, saying this is where add paths could be effective as well.
Sure, thanks.
Hi, Alvaro. Nicolas Antoniello from Uruguay. I just, if I didn't misunderstood what you explained, you basically mark the slash series 64 because it's more specific than the slash 61. How about if AS, in that example, if AS 65000 advertises a different slash series 64 block of the bigger one, of the slash series 1. For instance, I don't know, a different one.
You mean this way, upstream?
Yeah, instead of that slash series 4, a complementary one.
That is still overlapping by the 61.
Yeah, that's still overlapping, but how about if you want to do that in the normal way you do because you don't want to export the slash CT1 and the other ASN does not install that route in its routers. So you normally may do that for load balance purposes. You publish the bigger block, one small from here, one small from here. But if you discard this, you are screwing my load balancing.
Yes. Okay.
Wheel.
So that's excellent question, because that's the same question that we got at the very first time we presented this. Again, I'm not saying filter everything. If you have customers that are giving you more specific routes so that they can load balance, and you are telling them because they're paying you or because whatever, sure, pass the more specifics. That's your policy. What we're saying here is if you have a policy where you're filtering the overlapping route, you can use this mechanism. If you don't have a policy that filters the overlapping routes, well, don't put a policy that filters the overlapping routes. We're not recommending, nothing that you change your policies. We're just saying if you already have that policy, this is a mechanism you can use.
So just to be clear, you have to prearrange if you are going to be sending or not on purpose overlapping.
Right. So one of the reasons we showed it in this example up here is because probably this guy up here is far enough from the origin that he doesn't care anymore, right? So he may be fine with filtering the more specifics. Again, local policy. Peter.
Yeah, so, Peter Lofberg, this is slightly off the talk, but it must have happened on your mailing list that I didn't read. So why there are I can see two reasons why they're more specific is coming out of the 65000. A, they don't know what they're doing, or B, they're trying to do traffic engineering. Is there any other reason? And and my next question is going to be, what's the split between don't know what they're doing versus they do traffic engineering?
The first question, well, the answer to both questions is I don't know. I don't know if there are other reasons, and I don't know what the split is. But yes, I figure those are the two reasons. we see, or I mean, everyone sees that report that comes from Jeff, I think, and others, of everyone that doesn't aggregate, right? And that's or the one that where you leak all the routes, all the more specifics. And I know people who just advertise all the specifics just because they can, which probably means they don't know what they're doing. But I don't know what the split is. And I think Jeff is next.
So I have two comments. Jeff Houston. The first one, why do folk do this? When I actually asked one of the folk who are at the top of the CIDR report, why do you do this? Their answer at the time was, so no one else can hijack us with a /24. And I kind of can't argue with that. I make it seems a bit crazy, but it's true. The best they can do, the attacker can do another /24. Let's play routing games rather than more specific wins. So bear in mind there's a third thing. What kind of I don't know, just kind of gets me on this is you have a diagram where all this works, and then I sort of think, oh yes, I can do a diagram when it doesn't work. And part of the reason, I suppose, why I'm sort of getting up here is we've talked about this kind of filtering of either more specifics in various ways, proxy filtering, lots of times. And as far as I can see, the real issue is what I want to do in routing is trump your policy. That's what I want to do when I announce this stuff. So no matter what you do, I'm going to counter it because I'm going to win, and then you try and defend. So I'm not sure this sort of gets us anywhere other than you escalate one step up and I go, ha, you're escalating, let me escalate. So while I think that's fine, and in an abstract sense, you could knock out around 20-25% of the advertised routes. 600,000 down to 400,000, yay, let's go to the pub, everyone wins. In actual fact, you'll have 650,000 routes because I'm going to blat more in and through various ways to get around you. Because BGP is actually a negotiation policy, not an announcement policy. The protocol is all about who wins and who gets to determine this. So I'm kind of, I can see what you're trying to do and it's great. The pessimist in me says, yeah, not going to work.
Okay, so two parts to the answer. One is, I forgot what you said. One is, yes. Again, if you already have the policy, we're not telling you to go filter more. If you already have the policy, you can use this. So if you look back at IETF, whatever number it was in Prague last time, there was a guy who came and presented, he won the Applied Member Research Prize. He presented something called Dragon. Dragon is this, or this is Dragon, or whatever it is.
Right, so
in other words, what I want to say is that I don't have the mathematical proof he does. That, even if you, and what they did is, that we're not recommending, but what they did is they simulated this in a large scale. And for many of the policies, it worked fine.
Right, but just to even look at your diagram, I get a /63 somewhere, go around it and hit AS65004. Now, the reason why there's a /64 going that way is the originator, 65,000, wants the traffic to go, CAB or whatever it is.
Right.
All of a sudden, when you remove the more specifics, again, there's policy going on. What do I do in the result down the bottom? I work a little bit harder in advertising even more junk to try and get over this policy. So it's a war you never win.
Yes, so let me say this again. If you already are doing this, you can use this mechanism. I'm not telling everyone to go run out and change their router configurations. I'm not advocating the internet to go filter overlapping routes. I'm saying if you're already doing this, then you can use this mechanism. That's all. Very simple. Yes, very good.
Rüdiger Volk. Well, okay. I would change the discussion topic slightly. I have been thinking about policy a long time, and once in a while I did thought experiments where a feature like this was used. I'm not going to dive into what policies can be used. The question that occurred when I did do the thought experiments was, well, okay, what kind of feature is actually implementable in the BGP implementations? Saying, yes, well, okay, we introduce the generation of this community. Well, okay, that sounds easy. I'm not into the BGP code. I guess that generating and withdrawing attributes on a route depending on the existence of another route is actually something that is not straightforward. And so I really would like to ask some of the people who know how the code can work that are in the room, whether doing something like bounded and getting it withdrawn right and so on actually is something that is feasible. And the thing is, he has to.
I only play a BGP implementer on TV anymore. So yeah, I guess I'll try to answer that, which is, you know, everything can be done in software, right?
Who are you?
Sorry, John Scudder. It's not completely trivial. I'm pretty sure that RFC 4271 still says you're not allowed to, but you know that you can ignore things. But yeah, I think, you know, point taken that it's not a completely straightforward feature to implement. The thing I actually came up to the mic to say, Jeff mostly already said. I would want to agree with his comments. I will add on, I don't think he ever quite fully expanded out the example, which is, you know, the rest of the game here, right, is when AS65001 starts, you know, playing his filtering game, is AS65000, you know, takes that /61 and explodes it into whatever the, you know, hopefully minimal, but maybe not, you know, it could be all the 64s and starts advertising them.
Same answer, because it's the same copy that Jeff made, same answer. We're not advocating for anyone to go do it. We're assuming that 6503 is the one that has that policy right now.
And then that was my last comment, was to reply to your answer, which is, you know, spoken like a true arms merchant, takes one to know one. But on the other hand, since we're here in the GROW working group, if you don't think it's a good idea and you're not advocating for it, how are we making the internet a better place by publishing this RFC or this draft?
So I didn't say I didn't think that some people's policy are not a good idea. It works for them. So sorry, Robert.
Yes, Robert.
John, you have anything else?
We're going to cut off the mic too. So.
Yeah, I did want to follow up to that if it's okay, if we have time. So the follow-up is, of course, if all you were doing was enabling a policy and it wouldn't make any difference, why are you publishing a document that doesn't make any difference? The answer is, of course, it does make a difference when you introduce a convenience feature. And even though you know are saying a disclaimer, what you're actually doing by introducing a convenience feature is you're encouraging people to turn it on.
Okay.
So Robert Raszuk. So my comment is, you keep referring, Alvaro, that if someone has that policy, I understand that this is the policy to filter more specifics. However, the point of more specifics, as Peter mentioned, is actually the TE. And now we have the wide communities. As part of that, I collected a lot of feedback from operators, and they wanted to have one value which would enforce TE and hops away. So if that community is attached to 64 and you just delete it, you're making those lives miserable, right?
So again, that guy over there, 3, may already have that policy because he doesn't care what that guy is doing, what 65000 is doing, because, you know, maybe he's not getting paid or whatever it is. If the white community somehow says must never delete the route or something, right, until N hops away, then this policy should be applied because obviously that is a must, right?
But the meaning of the white community is actually make it preferred N hops away, right? So and your decision is lock AS path and next hop to be the same, and then you're treating them as bounded.
Yeah, and just one more thing, you know, people have filters today. They can do this today. They do this today, just with another tool, right? I mean, we can't sit here and say that we're going to take, you know, access controls and route maps away from people because they might do the wrong thing. They do the wrong thing already. Many people do the right thing, but you know.
Chris Morrow. So this strikes me as a lot like VA when I read it originally. And it kind of still, in the same concept, so it's sort of, let me reduce my individual routing domain or view, but still maintain reachability, right? Which you're doing. You're saying there's overlapping routes. I want to get rid of the small stuff. I want to save some space, time, memory, speed, what have you. I still want to be able to reach those places. So that seems fine, right? I think all the conversation about, should you do this or not? People, like you said, people already do it. If you're trying to document a process or procedure or configuration, I think that's interesting. I don't know that I would do it, but that's cool. Right? Everyone does their own thing. I think that it falls into like a consenting adult problem, like, right? You decide to lose routes in your network so that you can save money, time, speed, whatever. Cool. But at the end of the day, you still have to reach the rest of the internet. So there's some complexity that you're implicitly or explicitly adding, and that they may not save you money like you think it does. Which I think your document sort of says that, but at the end of the day, if you're documenting a configuration or a set of configurations, that seems fine.
Right. So again, I think people already do this. This may be just easier to do. Kair and then Shane.
Okay. Kair Patel, Cisco. I just wanted to have a follow-up comment that I actually think it will end up reducing the internet table size. For the reason that more specifics can be aggregated. It's very hard to spoof and inject the less specifics into the network because there are things like origin validation that you can enforce and weed it out. And if you can effectively start filtering more specifics at in your example 65,003, then you have a good solution. Now, obviously, if 65,003 has some sort of business arrangement with 65,001 to leak, then the policy should favor that.
So, Shane Amante,
we're out of, John, we're out of time.
I understand what you're proposing up here. I get the benefit it could provide. However, like Jeff, I have my doubts about its efficacy in the sense that if you think about these lines on the graph, there may be assumptions made about the interconnectedness of these ASs that is not necessarily true, or at least not necessarily true in certain regions of the world. Meaning, there are a lot of internet exchange points out there. There are a lot of providers, and not all, but a lot of providers that have a very set of rich interconnection policies. And if you look at your diagram up there, this basically will fall apart if 65,002 has a direct neighborship with 65,004, right? So
no, no, the answer is no. For 65,003, it won't fall apart because it is implementing its policy. Well, the effect is that 4 doesn't get all the specifics. That's not the intent, right? The intent is for 3 to filter its own stuff. Whatever happens behind them, that's a different story, right?
No, but what I'm saying is if I'm understanding correctly, you're attempting to only announce the less specific, right? From 65,003 to 65,004 to save table space in 65,004?
No, the intent is for 65,003 to maybe save the table space in its AS.
Okay. Well then, same comment still applies though, because he's going to need to be able to see or 65,004 or other ASs as they form these adjacencies are going to need to see that more specific as the interconnection mesh increases in density. So I doubt the efficacy of this proposal, unfortunately.
Is it quick, Rudiger? Because we're out of time.
Yes. Again, I know we are not in IDR. IDR should and needs to decide whether the feature can be done. Any feature that is introduced can help people to create bad policies. I know I could use the feature for things I cannot do without it that are beneficial for my network and do not have any external consequences except that I'm serving my customers better.
So the reason we're not in IDR is because this introduces no changes to the protocol.
So I think based off our discussion, we need more discussion on the list on this draft. So I think your next steps, you wanted a call for adoption. But I think we need a bit more discussion on the list based off the feedback today. So, thank you. So that's it. Our microphone doesn't work, but that's it for this meeting. We'll see you all in Berlin and on the mailing list. Thank you.
When do you fly back?
Saturday.
Saturday.
You're right.
Yeah.
Okay.